Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we have a problem today. We're going to be talking about circuits, and particularly series circuits. There's two kinds of circuits, series and parallel. Let's talk about circuits. Now, before we can talk about circuits at all, there are some sort of, shortcut ways that we draw circuits. And so let's fill out this table. So we've got wires, resistors, batteries, capacitors, lamps, voltmeter, ammeters. So we're going to draw diagrams of circuits, and we've got to have like a symbol. A wire's a line. You can also bend the line. A resistor looks like this. Can you see it? Kind of feels like, think of a resistor as like it slows things down. It's the quicksand, if you will, right? A battery or a power source looks like this. It could be a number of, it's like short lines and long lines. A capacitor, we learned about capacitance earlier. If you think about it for a moment, that kind of looks like, because there's a gap, because the electrons then jump across. A lamp is an X. A voltmeter is a V with a circle. An ammeter is an A with a circle. And I think we missed one. A switch, yeah. It's going to look like this. And that's a closed switch, and or open switch, pardon me. And a closed switch would just be like this. You just put that little circle right there and show that it's closed. Next up, let's define a series circuit. In a series circuit, basically, you're going to have a power source and then a series of resistors are hooked up end to end. And by the way, when I use the term resistors, I also want you to realize everything has resistance. And so this could be a light bulb, or it could be something inside your iPhone. And so when we're doing resistors are kind of the thing that we can have an actual thing that causes resistance, but we can also have it in sort of a device that causes it to do things. So a lot of the calculations don't always think of it as a specific little thing like a resistor, because this is actually what a particular resistor looks like. But it could be anything that does electrical work. And when you're trying to find the total resistance, we write this equation, we say the equivalent, or I think just total, the resistance total is just simply equal to R1 plus R2 plus R3 dot dot dot. So as many as you have. Let's do this example, and it's related to this cell. It says that this is a 24-volt battery, and that R1 right here, right? So there we got 250 ohms, 150 ohms, and we don't know what R3 is. They're asking also to find the potential difference across each resistor. So if we know the R's all add up to the same number, right? So it's R1 plus R2 plus R3. The problem is we know this. One other thing, of course, we know is that the current I is equal 0.032 amps. That's a 2. All right, so we can do V equals IR. I'm trying to find the total resistance. We know the voltage. We did this earlier in a previous video. We have, what's the voltage? 24 is equal to I, which is 0.032 times R. And when you do the math, you get R to be 750 ohms. Now, that's the total of all the resistance in this system. Now, we've got R1, R2, and R3, so you can say the R total is equal to R, and we know the R total is 750, right? Is equal to R1, which is 250, plus R2, which is 150, plus R3. 250 and 150 is 400. Subtract 400 both sides. R3 is simply going to be what? Yeah, I bet you can figure this out. It's going to simply be 350, right? Yeah. Ohms. I'm not drawing it very well. Ohms. Now, it asks for the potential difference across each. So what's going to happen is, as the voltage comes to R1, it's going to lose some of its voltage because it's going to get, some of that energy is going to get reduced by R1 and then R2 and then R3. What you actually do is you take your voltmeter and you put the leads here and here. You'll do this yourself in the class, in our simulation or in class per se. And so we know we're trying to solve for the voltage, we know R1 and we know the current. So if V equals IR, and I'm trying to solve for the voltage difference, so V1 would be equal to 0.032 times R1, R1 was 250, and you end up with 8 volts. All right, for V2, that's going to be I times R2. You might notice the current stays constant, but the voltage doesn't. And you just take 0.032 now times 150, and there you get 4.8 volts. You're going to notice a pattern here in just a second. NV3 would be equal to I times R3, and then R3 we now know to be 350, and I is 0.032, and you end up with 11.2 volts. Now if you add these numbers up, guess what you get? 24 volts. So that's how you do an example like this, a series cell. So it's not terribly difficult. They just add up totally, but you get voltage drops across here. You'd put an ammeter right here if you have a device and say, oh, and you would read this 0.032 device, and you'll be able to do this again in class to do these kinds of things. Series circuits, they're not so hard, folks. Houston, we don't have a problem. We'll see you in class.